Hey, welcome to another game development tutorial where we're recreating The Legend of Zelda in Game Maker. Today's episode we're going to focus on correcting some of the collision problems that we've had in the past, although most of you guys might not have noticed it, but I've had some viewers point out that if you change the values of the movement in the Octorok or Link, it doesn't actually work anymore. So I'm going to show you that real quick so you can see the Octorok's moving around just fine right now. We're going to close that and go into that object under enemies. And if I go into the create statement and I change his move speed to 0.2 and I do this again, he just spins there. He doesn't actually move. And that's because there's a problem in the code. So we're going to fix that. That's going to allow for the subpixel movement. So what we're going to do is we're going to go to the step event here. I'm going to show you what we had before. So if we go to the very bottom, we had this interesting code that was supposed to be doing subpixeling, and basically it was just rounding numbers until you got to whole numbers and trying to move once you hit a whole pixel, and that's what it would do here. But what we're about to do is going to allow you to do subpixeling without all this code, and you just pass in the value here and it will actually fix everything. So the way we're going to do that, we're going to go to our collision code, which is actually under scripts, utilities, and the collision, check collision object. All right, so what we're going to do is we're going to independently check for the X and Y collisions inside this loop, but we're going to take this repeat statement out. So we're just going to go ahead and take this completely out and this bracket here. We are going to keep this for loop because we are still passing in optional counters. And what I want you guys to do is copy this if statement for the if placement, because we're going to do it twice, once for the X and once for the Y. And what we're going to do is we're going to change some of this right here. We're going to say if place meeting X plus, and we're just going to say the VX that's passed in. And this one we're going to change and just delete it. So this is just if the Y gets hit. And now we're going to add a new parameter. In fact, I'm going to copy this a couple of times here. This underscore collision. And I'm going to copy it here too. And we're making new variables. One is going to be called X collision. So X collision, uppercase, and Y collision. We're going to check them independently. So let's do that down here. Just copy and paste those. And for the first one, since we're doing the X, we're going to say X collision is true, and we're going to take the breakout because we're not going to break out of that loop anymore. And then the same thing down here, we're going to do the Y collision, take the breakout, and let's actually fix this code. So we're not checking X in this case, but we are going to check Y. So just take the sign out and leave the plus VY. So here's what we're doing. We're actually just saying, hey, if we have not hit anything, or actually if we did hit something, say the collision is true. And so we're going to loop through all the potential things that we're checking for. That's what this argument is, all the potential solid objects. And if we hit any of those, we're going to say it's true. All right. So down here, after the for loop, we're going to move the X and Y no matter what. And this is what's different. We're going to just go ahead and move it. So we're going to say VX. And actually it's underscore. And we're going to move the Y into the VY. Plus equal underscore VY. And then let's bring this back. Shift tab is what will bring that back if you're following along. And so we're going to check to see if X collision is true. We're going to do the following. Take all this out. We're going to say X is equal to X mod, X div 8 times 8. take this out. We're going to copy this. We're going to do the same thing for Y, basically. Just I'm going to say Y collision and replace the X's with Y. So what we're doing here, when you divide whatever the X coordinate is, some number in the grid that we're on, when you divide it by 8, we're going to get a whole number back. However many times 8 divides into that number, and then we're going to multiply it times 8 again. And this is going to snap the whatever you're colliding with to the grid, but it's always going to snap it to the left and up. So if we're running into a tree from the right, this is okay. It's going to snap us back to the left. But if we're hitting a tree from the left, what it's going to do is snap us right on top of the tree. So we're going to add some code here. Actually, it's going to be a lot easier if I show you guys this, but I'm going to finish one thing here, which is we're going to say return X collision or Y collision. And I'm going to show you because I want to make sure that this makes sense for you guys why we're doing this before I add the rest of the code. All right, so we haven't fixed anything for the Octorock yet, but I'm going to show you when I move to the right, it does stop me. But you notice I just popped over to the left when I hit the left. I'm going to have to do that again. Okay, so when I hit the right here, but if I go from the left, I'm going to pop right through. So it's trying to snap me through there. So we're going to fix the code we're about to write is going to fix that. It also happens if you're coming from the bottom, but the top works. So the top and right work, but not the bottom and left, or top and left work, but not the bottom and right. So the way we fix that is we're actually going to check to see which direction we were moving from. So if we say if the sign of Vx, and that's just going to return either -1, 0, or 1. And if it's equal to -1, meaning that we were heading in the negative direction on X, or we're heading left, then we're going to say X plus equals 8. So we're going to snap it back 8 pixels to the right. And we're going to do the same exact thing for the Y coordinate. We say Vy. And everything's the same except for the Y's here. And all they're doing is the first code is going to snap you onto the grid once you have the collision, and this is just going to check to see if we need to snap you back a whole 8 pixels in the right direction. So if we play this now, so don't forget your parentheses here on your if statements. Okay, so that works to the left, the bottom works, and now the left works. So that fixes all the collision problems that we were having. And if you wanted to go sub-pixel movement, this will fix it. So let's fix the Octorock, and that'll be the last thing that we need to do. Okay, we're going to go into the step event, and we're actually going to take out all this sub-pixeling. We don't need any of it, so take all this out. And the only thing that we need to do to fix this is actually change this. Instead of Vx new, we're going to say Vx. Instead of Vy new, we're going to say Vy. That'll actually fix it. We're also going to clean up the create event. I think we have the Vx and Vys in here, so we don't need any of those, so we're going to get rid of it. And so now the 0.2 should work. And there he moves very slowly, but that's what we're only moving him sub-pixels at a time, but he now actually works. So sub-pixels actually work. Now this is specific to you having something that's on a grid. So when your collisions are going to be within 8 pixels. If you have something more complex than that, what I wrote there is not going to work for you. You're going to have to figure out for you if you have bigger tiles, or smaller tiles, or you're dealing with something else, but this is the way I'm dealing with it to make it more efficient. So that's it I was going to cover for today. Next episode, we're going to start working on the levels again. So I'm pretty excited about that. Thanks for watching as always, and I'll see you guys in the next video.